if okay, restream is up. Twitch, not yet. YouTube, not yet. Let's see. All right, YouTube preview is up. That's interesting. And Twitch isn't. Let's see if Restream has any complaints from Twitch. No. All right, Twitch got it, and YouTube. Oh, this looks weird. Oh, no, no, I think it's up. Okay, I think we're up. Well, welcome to the stream then. Well, I'm trying to figure this out. Okay, so I was away for a few weeks. There was SudokuCon, and I was there for 2 weeks, and I think I missed 3 streams in total. And then I got really sick, and I'm really gonna try to stream today because I don't want to miss so many, and I'm already forgetting how anything works. And because my brain isn't 100%, I'm gonna do something that's not like super critical, but it's something that came up recently because I very soon need to be able to reliably record and reproduce replays, right? And currently I can save them as GIFs from in here, but the process to do this is relatively expensive. Like, it takes a while, right? And I don't really have an easy way of doing that server side either. So ideally, the replay I'm collecting that I don't want just the raw data for it. I want to actually be able to visualize it, you know, animate it. So ideally, the person basically submitting the replay would also, their computer would also generate this additional data. So what I was thinking was that part of what takes a long time is the compression into GIF data in JavaScript, which I'm using an external library for. But the SVG data, the difference from one board state to another might be fairly small. So for example, this, let's say if I say replay save load, and we'll save it, let's say 1 frame per second, and 1 sec, it's, if I refresh this, it didn't stop correctly. If I undo, all right, you're gonna have to take my word for it. But basically, I think this was about just over 2 minutes or something, and I think it became. Oh, 1 second. I'm gonna find. Did I not? Yeah. So it became these GIF files. So that's the hard. Yeah. So 366 kilobytes as a GIF. And the problem with a GIF is there isn't really a browser native way of replaying it any other way than to just play it. And ideally, I would like people to have some basic control over it, like to be able to pause it, to be able to step forward or step back through actions and things like that, right? It compresses really well to 34 kilobytes because most of the frames don't actually change. So this is going to be a hard number to beat. So there's a couple of different things I can do. So one of the things I was experimenting with is to just like, you know, these are GIF players, but they really just decode the GIF, pull in the individual frames, turn them into an array of images, and then basically just manually step through them, right? And I could sort of do that myself. The other thing I was thinking, I can take this and I can create a screenshot of infinite fidelity as SVG data. Let's see, 512 by 512, right? And if I say download, right? So that's 27 kilobytes. Now, most of that 27 kilobytes is actually, let me just move these into the other thing I was using. So if I take these and I'll go to over here. All right. So most of that 28 kilobytes is actually CSS. And much of it is probably not needed. And in the future, I can maybe for this, I'll trim it a bit, but mostly it just copies all the CSS from the web page in to make sure that nothing's missing. And it's a bit complex because there's weird interactions with, you know, feature. Like, I don't actually know what CSS will be active, right? If somebody has some sort of plugin installed or whatever. So I'm pulling in a lot of CSS. But the puzzle data itself in SVG format isn't complex, right? And includes all sorts of information, including anything that visually changes, including selection and so on and so on. It's all in the CSS, right? Sorry, the SVG. So what I'm thinking is, if I step through the actions of a puzzle, just like I do when I'm rendering the GIF image, right? What if I look at the generated SVG data and create some sort of diff, like a difference between the two? And basically, I'll start with the base puzzle. I don't really touch it. And then for every change, I create a little group here, maybe with some extra flags or whatever. So it's not just additive, right? It's add and removable, some sort of class or data tag or something. And I'll just put the changes in there. And then when and maybe some information regarding timing, right? Because if I'm only recording changes, if for a minute nothing happens, I want to say, hey, nothing happened. And then after a minute, this happened, right? And potentially that data could be fairly compact. And on top of that, I might be able to replay that in JavaScript quite easily and step through the whole thing, right? So basically what I want to do today is I want to see if I can just what I do for the GIF here. So if we're looking at the feature GIF anim, I guess it's called, or puzzle GIF, or replay GIF. Replay GIF, here we go. And basically what replay GIF does, I think, is... so we have create GIF, GIF width, height, HTML progress. Yeah. So progress, last enemy, await create GIF. No, that's after the frames already exist. One sec. So create replay animation. So I think I'm first generating individual frames with get frames here. Let's see, get frames. Wait, this. Oh, I double name things here. All right. Handle on frame, total frames. Frames, get frames. Yeah. So basically this steps through the replay, and I'm thinking here I'm looking at times. Yeah, so I'm basically using the times to decide if, so basically it goes replay, replay, replay. Every time the replay forwards, it checks if the currently passed time exceeds the time I need for the next, sorry, there's noises going on in the background. It's amplifying into my ears and it's very distracting. 1 second, maybe if I change this. So it basically says, okay, the next frame is due in X milliseconds. We're adding the milliseconds of each action until we exceed the time for the next frame, at which point we're executing add frame, which basically converts the current puzzle to SVG because it's faster and cheaper than generating PNG data. And adds it to our list of frames. And then that's what it generates the GIF on. So the GIF is equally distributed frames. And this particular GIF library, and I didn't think about setting it up, doesn't do any checks if the frames have changed or not. And that's probably something I could add. But I think the first thing I'm going to do is I'm actually going to hook into this. And to do this, I'm actually going to download this replay. Replay save load. So if I just save that, right? And then I'm going to open it on my local version. Then I'm going to... Oh, this version isn't available. 1 second. It's probably suitable that we'll run the backup process as well. Anyways. But we can just go back in time, maybe go to March. All right, let me play this quickly. I'm actually going to play this through relatively slowly because I want lots of activity. So I'm going to pencil mark it and all sorts of things. So we're gonna restart, we're gonna do selections, we're gonna mark, you know, partial pencil marking and all this sort of thing. Nothing here yet. I do want to play properly anyway, though. So we got a 4 here, we got a 4 here, 4's here, right? 5's here, 6 here, 7. Let's hope this solves relatively quickly. So don't actually want to invest a lot of time. Meh. 999. 9. 9. 9. 9. This column looks big. Ooh, 9 here. This column looks really interesting. 1, 5, and 7. All right, let's do some selection shenanigans. These 3 we can also mark up. So I'll do that. I'm just gonna create some test data here. 5 and 7 are missing from this row. And this is 1, 2, 3, 4, 5, 6, 7. So 7 is here or here. So we got 7 here or here. 1s, 2s, 3s. Also here, only 3 cells left. 3, 6. Okay, gets us 6 there. Oh, no, that's 4 cells. Skip this one. So we have 3, 5, 6, and 8. Okay, let's checks out. 5s, 6s, 6s. I need to find a way of tightening my monitor a bit. It's just always wibble wobbles all over the place. Maybe the arm isn't at the right angle or something, so it's kind of swinging automatic on its own. All right. I think I'm gonna have to start solving a little bit of Sudoku. So 3's here, here. So this is 1, 2, 3, 4. So it's 5, 6, 7, or 8. All right. 4. 1, 2, 3, 4, 5, 6, 7. 1, 3, 6, 7. That's not great. I thought that would be better. 1, 2, 3, 4, 5, 6, 7, 8. That's also quite terrible. 5 isn't there. Maybe we can do something with 5s. Yeah. This row, is that interesting? 6 and this doesn't add anything. Wow, there's a lot of things that look great, and then you look close and you're like, wait, no, there's a whole bunch of digits missing. Like this, for example. I mean, this box only adds a 3, and this one only adds a 7. 1, 5, 6, 7. All right, 5. We've got a 1, 5 pair here. All right, 5, 1, 1, 3. Okay. Got something with the 1s here. 2s, 3s, 4s, 5s. 5, 5, 5. Okay, 3, 4, 7. 4, 5, 4. 6, 7, 8. Okay. 5, 8, 2. I feel like, I don't know, this is a weird one. Both, it seems too easy. Like, did I make a mistake somewhere? Like, I strongly feel I made a mistake, but I can't think of where I might have done that. Ooh, 7, 9 over here. Nope. And these 3 are 1, 2, 6. And these would be 3 and 8. Like that. And this would be 1, 7, 6, 8, 7, 7. And these 3 are 1, 2, 9. All right, 7, 9. These are 3 and 6 in this order. And these two are 2 and 3. And yeah, normally I don't start the episode with a solve. It's usually my reward at the end. Sometimes you need some test data. And especially when you don't prepare, like I do not prepare. The whole point of this is getting extra work done. All right, 6, 8. Preparation is work. All right, Toby's about to leave on his walk. In case you guys were hearing him in the background. Ciao, guys. Have a good walk. And that's a 7. All right. So let's pull the SVG screenshot. We'll do this like that on blank puzzle. So we want to download that, and then we want to replay, save, load, save file, and then we want to do replay GIF, and we are. Did I not? So if I refresh, I don't know what the timer is buggy as all hell. All right, 5 minutes 44 seconds, right? So that's 5 minutes is 300 seconds. So 344 seconds. So let's make 344 frames. 344 frames. And that's fine. And now we'll create that animation. And this is a process. Yeah. So it basically adds a frame every time it exceeds the required number. Wait, what? 1 second. Just did my YouTube stream just die? What's going on? It says connection error state. 1 second. No? So for some reason, Restream has 2 YouTube connections, which is very strange. Connection error state. Okay, I don't know what's going on here, but everything looks good except a red X next to a YouTube logo. But there are 2 YouTube logos. One does not have the red X, so Okay, well, let me know if there's any problems. I would love to know if there's any problems. Please let me know if there are problems. Alright, I'm gonna leave the stream open. I don't normally like doing that, but I really don't trust this thing at the moment. Okay, so, wow, it's just playing the GIF now. So if I download this now, right? So we have a 512 kilobyte file, and we have this SVG file that we can probably, no, that's not the SVG file, that's the replay data. We have this SVG file, yeah. Okay, so now what I'm gonna do is, I'm gonna look at this is what's generating the frames. So we don't really, yeah, basically instead of doing it this way around, basically every action, I need to figure out a way of basically basically checking if the SVG has changed, right? And ideally efficiently, because there's usually more actions than there are frames, right? By a lot. So puzzle to SVG is from the utilities library. So let's have a look at that function. And that I think does, no, wait, it's puzzle tools, isn't it? Puzzle tools. God, I've never, that whole part needs a bit of cleaning up. Because it does all the heavy lifting, I think, with bringing in the SVG styles and all that stuff. Yeah, here we go. Now, this generates a separate SVG document, which isn't what I want, right? What I need is to just have have 2 SVG DOM element things, right? So there's a way of cloning an HTML element, right? Clone DOM. So we can clone node, right? So node, clone node method, clone node, insert different document use. Okay, so first of all, let's see if we can just break it after the first step, just interrupt whatever is happening here. Ultimately, we're obviously not going to run this in here, but I know there's a whole bunch of setup I need to do. Like it's making sure the previous state is like to basically reset to the beginning of the puzzle and then fast forward through replay data while also holding on to the replay data is just, you know, it's a little dodgy. So replay play, speed 10,000 play to time. So I think this replay play to time -1. Yeah, so I'm gonna have to remind myself exactly how this stuff works. But I think -1 tells it to just do 1 frame. So replay play, and it'll do play to time -1. So play to time is -1, play to time is -1. Play time, yeah. So if it's not -1, it does this. But how do I control how many frames get replayed here? Be 10,000. Oh, I do not, right? So now I remember. It's using the handle replay step callback here. Okay. So replay time, play to time -1. So this sets, okay, so this takes us to the beginning, and then this takes us all the way through to the end. And then this triggers each step. So if I do this in here, and let's do it with a short animation, so like 34 frames, for example. If I do this, I'll have to reload, right? And apparently I've managed to not break the current replay in memory if I pause it in the middle of doing that, so that's good. Good job, past self. All right, 5 frames. Create animation. Yeah, so handle replay step triggers many times. So even though we're just generating 5 frames, it actually takes quite a bit longer to generate because basically running the replay by a step and then doing a bunch of housekeeping takes a non-zero amount of time, and doing that 9,550 times just adds up, right? And it's async and so on. Hey, GDC, thanks for stopping by and letting me know. Good to hear that the stream is okay. Okay, so this triggers 950 times. And once at the start, and then at the end, I think it basically just jumps it. How does it trigger 1 extra time? I don't know. Maybe the final, it does 1 more or something at the very end. I don't know. Okay. So, now let's look at, so we have our SVG document, right? So you can do, oh, actually, I think I can do a framework.app.svg renderer svg renderer .svglm. Right. Now, in theory, I think I probably don't have to clone the whole thing. Like, I could literally just watch the different thing. But like, I'd like it to work even with things like fog puzzles and stuff. So we might have to clone the whole thing, and we might have to see how heavy that is. So what we might do is do it once at the beginning and once at the end. I'm trying to think. Let's see if there's a built-in way to diffing a DOM element. Like, is that something we have to manually do? Library allows abstraction of difference between DOM elements as a diff object. Result of modification must be applied to one element in order to turn it into the other element. The diff is non-destructive, meaning that okay. Now, I'm presuming this just does a manual walk of the thing, of the DOM branch. So there's probably not really any shortcut. Apply undo from virtual. Yeah, I don't want to go crazy, to be fair. If I can find some simple tips on how they do certain things, like how do they compare to elements, right? Like, do they diff DOM index const names diff DOM default options? What's the actual diff DOM root function? Okay, let's have a look at how this is supposed to be used. So the way it's supposed to be used, diff DOM.diff DOM. Okay, so there needs to be a diff DOM function somewhere. So if we go in here, is there a diff DOM? Constructor, undo apply diff. But I don't see a diff DOM function. Apply undo diff from helpers. Import diff from help. Default text diff. No, we will return empty function when benchmark is running faster than both. Empty functions where benchmark is running faster than both f and f. And if f. Oh, so they, okay. Weird. All right. Class diff DOM. Now this thing as a constructor, where are the diff function calls? Diff finder. Okay, so what's diff finder? Diff finder is inside virtual. Diff finder is inside virtual index. Okay. And diff finder comes from diff. Okay. Just make me chase my tail. Okay, and that's huge. All right, fair enough. So what I'm expecting this to have is equal and so on and so forth, right? Suppressed, a diff length check the really the same now. Diffs, find next diff, find next diff. This option maximum. One dear counter text. Hey, all right. I don't need it to be super performant, so I'm gonna, because what I'm thinking is like, do we want to turn the whole thing to a string, check if they're the same or different? But that could be really expensive, right? And if we're gonna walk the nodes, then we can find exactly where the diffs are. If we're gonna have to walk all of the sub nodes and whatnots. The problem is right now it's not even clear to me how I compare two nodes generically without doing some weird insight into, you know, I don't have the knowledge what kind of attributes I have to compare between SVG elements, right? Now for my use case, it's not super critical because I can probably simplify it quite a bit. But I was hoping that this kind of tool would help me with that. But so far, if E equals unequal. So E1, E2. E1 equals T child nodes I. Of different amounts of child nodes. A remove is necessary to obtain the same length. If difference, okay. If E1 is not equal to E2, okay, like if they're not literally pointing at the same memory location. If they're text, do something. Node name equals hash text, okay. Else diffs if text if e1 clean node e1 that's 1, else if is not equal, else if and oh wait, it and not e2. So if one of these is undefined, okay, never mind. If both of them aren't undefined, find next if e1 e2 is equal e1 e2 is equal. Okay, so is equal, is that defined here? Ah, okay. That's what I was looking for. Okay, so it specifically looks at attributes. It looks at a bunch of stuff here. Roughly equal, okay. All right. The question is, can I use this? Is it large? Can I build this for in-browser use? This library allows the abstraction of difference between DOM elements as a diff object. Represent the sequence of modifications. Diff is non-destruction, meaning the relocation of DOM nodes are preferred over remove insert operation. Preferred over remove insert operation. Okay. This project is licensed for demo and tests. In the browser, we can do it like this. Or if you like to infer from npm and npm. So here's a test of random elements. It is executing right now, I think. Yeah, this tab is busy. Okay. Wow. That wasn't great. Why was the renderer crashed? Okay. That was weird. Okay. Don't know what this is supposed to do. Try this one again and see if it hits 100% CPU usage again. Does seem to be. Why? It can't even do any of that. Can I pause the execution? I don't want to waste my time if the thing doesn't work. All right, let me close that. Is that still gonna burn CPU time? No. All right. What about visual DOM? I don't need anything visual. 6 years ago. How old is this thing? Diff DOM. Years ago. Any issues? Compare to HTML strings and highlight differences. Compare to merge them and highlight in green and red. No. I need something really simple. Build DOM diff. Returns a new document fragment with the content from the two input nodes annotates indicating that given fragment was removed, modified, added. Let me think. I mean, ideally the change would be minimal. But I kind of have a good idea what actions can and cannot do. So it might not be that hard to kind of customize it and special case it and just say, hey, you know, if one of these layers changes, I'm really like, if this thing works, I'd love to try it. But the fact that the demos don't work is a bad sign, right? Although one of the demos did work. But like, This, okay, no. Like, I don't want something that, if it doesn't tell me that it's gonna run for a while, I'm gonna wait forever. I'm just gonna assume it's not working. Yeah. Why? Is that a lost abstraction difference between diff object? Tests are run using JS. There are some browser-based tests you can look at. Demo. Interactive demo. Okay. Input, output. This is a video.
Hello, my name is Alex Smetcher from the Public Knowledge Project, and this is a demonstration of a technical feasibility test we did on integration between Fidus Writer and OpenJournal Systems.
What?
Fidus Writer is a web-based open source word processor, and OpenJournal Systems is an open source...
Wait, what? The output to the right corresponds to the HTML entered on the left. Synchronization always takes place after a change of the input field. If the HTML in the area is valid, synchronization does not take place until it's valid again. Notice how elements that have no changed are not touched. For example, try to start the video and then change something. Oh, okay. This is a ABC test.
As author.
Okay, okay. The video has nothing to do with any of it. All right. So what does it exactly do? So text area on input, new element, blah, 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 success, failure, false, add, remove. Inner HTML has to be adjusted to take the text area value. This means the HTML was valued. Yeah, inner new element, inner HTML. Okay, whoa. So out diff, create element, diff DOM, out diff, text area, create selected text area. It's our input. The out diff is that. dd apply out diff, dd diff, out diff diff. And the diff is output in the console. Ah, here we go. Diff E. So it's an array. Modify text as this is an A. Okay. So that could work. We need a place where I can put this so I can try it out. I'll probably need to put it in the site directly. Let's grab this. I don't know if there's some sort of build process or something. Like the demos, what do they include here? /browser diffdom.js. Okay. /browser diffdom. Okay. So I should be able to just download these. Right. And that should just sit here. Did I not get the map file? Okay. And then we'll put it into the site. Let me make sure the site doesn't have some garbage in it right now. All right, only the garbage I'm putting in. Good. That's the good stuff. So staging. Let's put that here. And let's look at the demo HTML file. So if we just do that, so if I just put that in here under here, script, just like that, will that work? Okay, it's there. Diff DOM. Okay, so the object comes into existence. So we need two things. We need to be able to clone it. No, wait. How does it get the before and after? So it says dd diff out diff new element. So the out diff and the new element. So the out diff Add success, add text error, diff, out diff, d apply out diff, diff, out diff, new element. The new element, inner HTML, so that's, okay. Okay, so we can do something very simple. We're gonna create our, because I can do undo, right, to make an actual change or redo or whatever. Sorry, my brain is not working very fast, so I'm as frustrated as you guys are. And if you think normally I'm too fast, today is a good day to try following along then. So we have this, right? So we have we'll do right, and then we'll have diff-dom, which should get created like this, right? So we can do this, and we have something like this and the diffs. All right, now only issue is we have currently in this situation we only have one state, right? So if I do whoops framerec.app.undo, I do this, and I'll do redo. Oh, it does repeat undo. Whoops. All right, so if I do undo once, redo once. Okay, so we should be able to do undo once here, and then redo once to get back to the previous state. And then here we need to clone the node. And we had a doc up for that over here somewhere. Clone node, clone node, clone node. Return value of the new node cloned. All right. So if I do clone node new node deep, right? We will say let clone. All right, and then we'll say clone equals svglm dot clone node deep, like that. And now we'll diff against the clone against the element, and we output the diff, right? So if we do that, what do we get? We get a diff of 1, which has add element. So it added a text value, attributes x, y, cell values, style, nothing, class, cell values. So if I look at the source of this SVG, does it tell us about the location? Child node, node name, text data 7, okay. Route 2956. So I'm guessing route is the location of where this happened. All right, now that's a problem because that's some sort of internal meaning. Okay, what does the route mean? Find route. Filter route. Nope. Disable value diff detection. The forms have been filled out by a user in ways that have changed with which values associated with an input field or which options are checked selected without the DOM having been updated. The values are diffed for user cases. Original change have been made. Okay. Debug true. For debugging, you might want to set a max number of diff chains between two elements before diff DOM gives up. Okay. Let's say standard behavior of the diff by returning true from this call. This will cause the diff apply function to return premature, skipping the standard behavior. Inner and outer diff hooks. Way to filter outer diff. Change current outer diff by returning the new area. Advanced method of two text node changes. Pre and post diff hooks. Yeah, the issue, it seems like it doesn't really document the format of this diff object. And I'm guessing the route is kind of important here. So let's have a quick look at something route. Index, apply undo. Virtual apply diff from DOM helper index. Doff diff. Find route. Route. Find in a diff route. Number array, route length. So I'm guessing it just references roughly some kind of count, like if you're stringing out all the elements or something. So I'm guessing there's 29 items and then 59 items. I don't know. I mean, the one that's changed is in here. So cell value was changed to a 7, and it's fairly far down here. So I'm guessing this is 56 children here. Can I get properties? So children, I'm guessing there'll be 57. Okay. All right, and there might be a text node in here somewhere as well. And then I'm guessing there's a roughly, what was it, 29 objects above it. But does that include all children? So I'm guessing it says from here, find child number 29. Wait, let's see, children 15, no. Child nodes 31. Let's see, 29. Ah, okay. So it's an index into child nodes values. So child nodes. Wait. Child nodes here. Then we go to here, 29. Nope, I didn't mean to press that. Which takes us to here. Now we're child nodes 57. Okay. And now we're not looking at 29, we're looking at 56. And that's 56. Okay, so these are simply indices into child nodes. Okay, that I can work with. So let me just refresh my mind on the undo function, what the actual arguments are. Undo, auto repeat, redo once, repeat, auto repeat function. Auto repeat, undo delay, repeat, undo interval. Auto repeat function. God, if I don't fucking remember how that works. Excuse the F-bomb here. So delay interval auto repeat function. How does it stop it though? So it should return this. So there should be something like dot undo dot. Like how is the undoing being stopped? Undo. Later undo. Auto repeat. Handle func stop func. Start repeat. Repeat func. Start repeat. Handle func. And stop handlers. Stop. So dot stop. dot undo. One click. Undo. Because I believe if I click undo and then hold it down, it does multiple undos. I don't know how that works. And if I release, how does it stop the undoing? Auto repeat function. Oh my god, it works well, and but I don't have I don't remember how I implemented it. Repeat undo interval, get settings, repeat, blah blah blah. Yeah, so it's using undo once and then repeat once and redo once. And then it's doing undo. I almost want to put something in here. Like if I do this, right? And then I just press this. So when I release, stop func is definitely getting called. And there's nothing. No absolutely. Maybe it's not being called from here. Maybe it's getting called from something else. Oh, okay. Anyway, stop event names. Okay, so blur, focus, page out, key down, key up, mouse down, mouse up. So all of those cancel the repeat. Okay, so it auto cancels like that. Okay. All right. All of this just to remind myself that I cannot pass arguments in that tell it how many times to repeat. Okay, that's fine. That's fine. Wouldn't have been a good idea anyways. So, excuse me, all of this to create a slightly better demonstration or test by just doing this a couple of times, right? So we probably want to do app colon boom, colon boom. So that's that, right? So we have app, of which we have SVG render. All right. So then we can do this 3 times, and we can do redo 3 times, and now we can get a different diff, basically. Yeah, and now we have 7 changes. Now the question is, how big or small are those changes, and how often will we have large ones, right? Now these changes aren't in a minimal format as I would have liked. Like I would have liked just kind of literally yeah. Anyway, these things aren't compact, but we can experiment and see. In fact, we could probably just go through the whole thing with undo and redo and get an idea of how big these changes are. And we can do it in reverse as well. We can just step back 10 times and step forward, or do the other way around, right? So let let step count equals 20. And then I can basically have 20 different diffs. Clone diffs. Right? Then we can say, okay, for blah, 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 or let s equals 0, s smaller than step count. We'll do undo once. Right? And then we'll do step count. We'll do redo once. So we'll step forward again. And now each time we want to clone the node, generate a diff. So we'll clone it. We'll redo once. We'll do a diff. We'll do a diffs.push diff. Right. And then at the end, we want to say diffs, right? And we want to get the sizes and like an average size, right? And right now I'm just gonna, hey, ESC Mateos, how are you doing? I'm gonna just use the size of the JSON string. And just to get a rough idea. Maybe this whole thing is stupid, but maybe it'll work. All right, so we want to do let size equals JSON stringify diff dot length. Right, we have diffs, we have sizes, or yeah, we're just total size, right? Total size 0. We can do this up here. Log. Okay. Diff. So that's S in size. And then we'll output the total size. And average build size divided by step count. Right. And that should give us a bit of an idea what 20 frames of this kind of animation would cost us in terms of size, right? It just, yep, or not. Probably missed a comma somewhere. 7. That's S was that. All right. Reading push. Diffs is not an array, right? All right. So 68 kilobytes in total, average 3.4 kilobytes. That's big. That's quite large, I think. So that's really inefficient. So this is a very inefficient way of storing them. Because, for example, we don't care about the old value, yada, yada, right? So I need to modify this. If I want to use their system for applying them, I need to have it two ways. But we can maybe do a quick one-way version, right? So we'll do a little function. We'll call it something. Enc diff or diff enc. We'll take a diff, right? And the diff has multiple actions. It's an area of actions, right? So we'll actually do a diff action encode. Action, right? Action route name, old value, new value. Modify route. Okay, so the route is an array of numbers, so we can leave that as an array of numbers. The JSON will still make it a little bit inefficient, but we can probably deal with that. Let's look at something like modify attribute, right? So the diff is just an array of actions. So we'll do return diff.map diff encode action, I think. All right, let's do 3 steps. And we'll output this size, We'll output the diff itself. And we'll output the encoded diff. Something like that. Also, our thing here didn't go all the way back, which is interesting. We got a problem again. But the encoding doesn't do anything at the moment. All right. So we have a diff, which is an array of 2 actions. And currently that just gets converted to the same thing. Cool. So now we can do switch action default console.error unhandled action. Right. Unhandled action. Now, if it's a case of add element, then we want to return a new array. Let's say add element is 0. Add element will have a root, and we have an element definition. And the element will have attributes. Okay, so we want to encode elements as well. Right. Route. And then element, right? So diff. All right, let's change this. Enc diff. We're encoding the diff. We're encoding the action, and we're encoding element, because we might have to reverse all of these in the future. Encode diff, encode that, encode action element. And the element has all these properties, all right. Console.log. Well, the attributes are key value pairs. The child nodes are they just other elements? Node name. Yeah, so it's got a node name. So we'll start with the node name, right? So we'll return array cl.node name, then el.attributes as an element, as an object, and then el.children, child nodes, something like that. I think that should be that. Then we can do an element. Oh, just data for now. So we'll do data action, data.element, data.root, data.action. All right, let's do that. Unhandled action, remove element. Yeah, sure. So we have remove element. So remove element, what does that look like? Remove element, root element. So when we're removing an element, we don't need the element at all. We can just do this and route, and that's it. Boom, remove that element. We don't care about the rest. So we'll do that. Modify attribute. Now modify attribute. We don't need the old attribute stuff, right? So modify attribute. That's gonna have extra quotes, isn't it? So that's just item type 2. So we have a name, So we have data.name and data.newValue. That's it. We don't care about the old value. With those threes, we have the encoded actions. The question is, decoding might not work without the old values there, but we could inject those during the replay, because obviously as we're reconstructing the thing, we have access to the old values, right? So for now, let's do this and figure out what the encoded sizes are. So we have this, and then we can do encdiff. Let's say let enc goes encdiff, right? And then we can do json.stringify enc.length, total size 2. And now let's just bring that up here. And that's the second one. All right, so that brings it down to a lot less. Is it small enough? I don't know. Let's run 20 of them. See if it breaks. Okay, so we have a bunch of other ones. We have remove attribute and add attribute. So we have modify attribute. Let's make that 3. Then we have, actually we'll do add attribute 3. Remove attribute 4. No. Remove element, add element. I don't know if modify element is a thing. There's modified text element. We could do make this 2, 3, 4, 5. So let's have a look at add attribute. Add attribute. Diff. Wait. This should give us still the raw diff without the encode, without this modification, right? I want to open. I don't want to open this. I want to open this. Oh, it's not letting me extend that one. Oh, no, it did. We add attribute. We have a root, a name, and a value. So name and not a new value. So that's add attribute, root, name, value. Okay, that's add attribute sorted. Now we have, here we go. So remove element we've done, modify attribute, remove attribute. So name and value. Remove attribute is also name and value, except we don't need value here. And modified text element is the one that's, modified text element is just data dot new value. So data route data dot new value. Okay. So add attribute, remove attribute, modify text element. Okay. I think that's all of them. Yeah. Okay. And then at the end we get 771 bytes per, on average per change, a total 15 kilobytes. The problem is this might not be very compact compared to like compressed GIF data. Because compressed GIF data, removing a character could be very small, just a few pixels, right? While rendering the character as SVG data might, or the line element or something might add a lot of this stuff, right? So for example, if I look at these, Let me actually look at the JSON data itself as well. So if I have diff and enc, so instead of the diff, we'll do this. And we'll also output the JSON here. And we'll do the same thing up here. So we have a diff here, but we'll also do JSON stringify of the diff. We can look at the JSON string. That might actually be a bit bulky. I might not like this. Yeah. All right. Is this compact? The problem is some of these I don't technically need, right? And I can make them smaller. Like, I don't need all this quoting and all this sort of thing. But how far down the rabbit hole do I want to go, right? And do I need the XY coordinates and things like that? I mean, at some point, I can just have the replay data, basically. Yeah, that's the other problem, right? If I make it too complicated, then it's just the replay data. Sorry, if I make it too compact. All right, let me skip this. Go back to just outputting the final, right? For now, I'm not even looking into if I can actually reverse that. And let's see if I do this 100 times. 100 undos and 100 redos. Unhandled action, relocate group. Ah, okay. Okay. We actually want to do this. So we actually want to do this. So action relocate group. Okay, so that's a new one. Relocate a group. That's going to be 6. So we have, do we care about the group length? Route 27 from 9, from 0 to 2. So I'm wondering, do I need from and to when I have route? Is from always going to be 0? No. Is this like a reordering? Does the group length matter? Yes, I think all three matter. So we'll have data.from, data.to, and data.group length. At least like that, it shouldn't be a large change item. So now we're getting up to 1115 per change and 115 kilobytes. It's starting to get larger than the GIF would be, which is silly. Although I'm saying that, I did create a GIF for this, right? And the GIF is 500 kilobytes, not 115 or 111. And that's also perfect fidelity. The undo redo mechanism is not a good stand-in for actually going through the replay. Although it might actually be pretty good for things that cause changes. It would be good to know. I'm just thinking, can I automatically detect how far back in the replay data I am? Like how many undos are in the replay, right? Until I get to the start. Let's see. Diff. The diff itself is an array, right? So if I say console.log log s and diff.length, right? So that should just give us a bunch of lengths. Will it ever give us a length of 0? It hasn't so far. If we make these 200, go boom. Then we get a bunch of zeros. And then we got back again. Okay. So when we have a diff of 0, it shouldn't add to the total. And the only diff of 0 should be at the very end. I'm pretty sure there's undo redos that could cause a no change. But this it's around 200 undo redos for a 960 action replay. Does sound about right in terms of yeah, so it's just removing selections at the very end. Yeah, because we're going also in reverse, right? Wait, are we going? We're undoing first and we're going forward. Oh, and then oh, that's the last. So if I undo here, I just get the selections. And the undo is like the removal of the selection. Okay. Yeah. Y 448 512 modify attribute. New value. Okay. So 189. We do 189. And then we'll do this. Boom. 87. All right. So the final replay data is this. 166 kilobytes, which is actually perfectly fine. Now the question becomes, can we reverse that? So the question is, can I reconstruct the SVG just from this replay data using this diff tool and their apply function, right? I should be able to do it manually if I want to go through that. And I want to record these as well. So our anchs go here. Right. And we'll do that there. We'll output the anchs as well. And we'll also do anchs.length. JSON.stringify anchs length. Right. And that should get us the actual full size of this, which might be a bit different from this. Yeah, it's just a couple of extra commas and all that stuff, right? So that's not too bad. It's not too bad. And there's some options for reduction. In fact, I'm kind of tempted to output that as well. Oops, no. Let's not just erase it all. Let's think. So that would be 167 kilobytes of diff data. I mean, ideally we get rid of all the quotes, quotation marks and all that. Node name data. Node name data. Node name data. Node name data. I'm curious if that's like I can simplify that. I mean, it's mostly all the quoted values. Like these could be unquoted, these can be oh, these should be unquoted, right? In fact, if I do this, and I just say find all, how many? 26,000. So that's 26 kilobytes of double quotes. And we can maybe even. I'm just thinking, like, if we put each one into it, like if we just line break between each action instead of commas and get rid of some of the braces and stuff. There's a lot of formatting characters in here. node name. Why is there the full-sized string node name in there? All right, let's do a proof of concept of decoding it all, and then I might have to call it a day. I'm not feeling well. Sorry, guys. So first, before we do that, we'll go back down to a much smaller step count. Right? And then the idea would be to kind of go back by one and then apply the diff, right? So to go back by one, if I do this at the end, right, we get back to here, and let's just disable that. Check on finish off, right? So that gets us to here, and then if I apply the diff, let's figure out how that works from this thing here. Apply. So element A. So we do this, and the element we're applying to is the SVG element, and the diff we're applying is the only one we have, right? So it's diffs 0. Right? Yeah, I figured that would break something. Oh, no, we're back. Wait, what the heck? Why does it take so long to come in here? That's a bit odd. All right. Oh, wait. I'm trying to remember. Are my diffs in reverse here? Okay, let's do something different. Instead of doing all of this, right, we'll create our clone before we do undo once. Then we'll create our diff, clone SVG element. We'll output the diff. Now, if we apply the diff, it should bring us back, or do I have to reverse this? Cannot properties undefined reading parent node. Console log diff. Parent node. Clone and SVG element. So we have that. We get our diff. Reading parent node. So I'm guessing I need to apply it in reverse. So this has a remove element. So if I do it this way around, we should get an add element. So weird why it takes. I don't know. Okay. And yeah, there's an extra 7 in the DOM now that my software doesn't know about, basically. Okay. This should still be the same, right? Yeah. Let's do something here. Await sleep 1000 like that. So console.log. Let's do the clone node, then we'll sleep, then we'll do the undo once, then we'll sleep, then we'll do the diff, then we'll do the apply. Right? So it should go boom, selection, and it comes back. And the diff is 2 E's. 2 remove elements. rectangle and path. Rectangle and path. I create both of those? Possibly. Okay. And now we'll do basically the same thing. Let's make these a bit shorter. But instead of all of this down here, we'll encode the diff. Right? So we'll create an encoded diff that enc equals that diff. We're outputting this, which should be the smaller thing. Okay, and that basically gets us these arrays, and they should be, shorter. So a 1 is simply remove element at that location. We don't care what the element is, right? So now we need to decode. Right? Let's change this to data. So we'll do this same thing, decoding. But now we need to reverse it, right? So add element, no. So now we'll go switch data 0, the first element, right? And we'll go case 0. All right. So case 0. I think we're going to do this, right? Kind of want to do the same thing here. Right. So in case of case 0, we need to return a new object where action is add element, where route is data 1, and that's it. No, and element equals deck element data 2. Right? And then we need deck element. And it's going to be an object. And it's going to have a node name, which is data 0. It's going to have attributes from data 1. And it's going to have child nodes from data. Now, child nodes will probably want to map to encode element as well. Right. And child nodes is data 2 dot map deck element, basically. Right. So if I do this, undefined reading map. Properties of undefined. Data to child nodes is probably undefined, right? Oh. So this probably should be Well, actually, it could just be no, because I don't want. I'd rather have an empty array than the word undefined, right? So we kind of want to do this. And we'll probably want to do the same thing here. Right. And then we'll do the encode of the decode or whatever. Why are you highlighting that brace? Do I have an error in here somewhere? Why are you complaining about that brace? Don't scare me. Don't make me nervous. So we'll do decdiff of encoded. And that should re-decode the encoded. Where's the break? Decdiff is not defined. Dec action. No. Alright. I just misspelled it. Bear. Okay. Unheld action. And the action is number 5. Alright, so now we need to implement all the other ones, right? So case 1 is remove element, and it only has that. Case 2 is modify text element, and that has root and new value. All right. Case 3 is add attribute that has name and value. All right. 4 is remove attribute, and that only has name. We don't need value for that. And 5 is modify attribute, and 6 is relocate group. So now modify attribute has name and new value, which is the same as this, which should be 3. Wait, new root, new value. Okay. Value, new value. All right. And then relocate group is as route, as from, to, and group length. And I hope I didn't remove something here that's required. Length. So 2, 3, and 4. All right. That should cover them all, right? Now, these aren't the correct thing. They don't have like a prototype and all that. Does that matter? Function E. E entries for each return. What? To string 5, this set value. So E entries, object entries for each turn tn equals 0, t equals this, equals O. Okay. Can we create these E's in here? Apparently not. Oh. Okay. These aren't exposed. So this is inside diff DOM. Okay. So diff dom is exposed. What? Diff dom. Okay. What does it expose? Okay. Node to object. Node to object. Y. Node to object. E dot data. String to object. E. Okay. No. So diff dom dot diff dom is this. No, it's the whole thing. Okay. One sec. So when I'm using diff dom, I am doing this. Excuse me. Name E. Under diff. All right. We need to extract it from here. You know what? We don't even know yet. We don't even know yet. We're just gonna try it. So if I do JSON.stringify of this and of this, what does that look like? Not of that, of diff. What does that look like? Not the same. Action. We have 4 here. We also have 4. Modify attribute. I mean, we're skipping the old value stuff. That's fine. At least I hope it is. Remove element. We're also skipping adding, showing the element for remove element. Element is undefined. Add element. Element is not undefined here. Why is element undefined here? So in the encoded, the last one, we have an area of 3. We have the root, we have that. What is this? This is of type 0. Add element, root, data. Oh, that's not a function call. This is a function call. So now if we look at the last one here, element, right? And here we look at the last one, add element, and element is got some attributes, got some child nodes, got a node name. And the child nodes themselves should also look right. They're not. They do not. I think we gotta get a little bit better at this here. So const res equals array with these. Boom. If data.child nodes res dot push dot map encode element, like that, right? And then return res. Boom. And then decode will do something somewhat similar. We'll say const res equals this, attributes that, right? And then we'll say if data 0, 1, 2 res dot child nodes equals something like that. Boom. Turn res up. All right. So now, ooh, what's going on here? Wait, what? if data dot child nodes map encode element. What the heck? Huh? Oh, okay, wait a second. We've been kind of drifting. I don't think I've been resetting the state of the board. Now if I redo, we should be fine. Yeah. Let's have a look again. Add element has one child node, has child nodes, element, child nodes, node name, text attributes undefined. Node name text data 7. Oh shoot. Yeah, let's see. Log. Object dot keys data. I think I have I think attributes child nodes data is one of these not like the others. I think one is one sec. I think one of those is the text thing, so we might have to just encode that from scratch, not using the encode element thing. So enc action add element is text, and then child nodes is node name text data 7. Oh, are child nodes encoded differently? Ooh, okay. If I don't do that, right, and then instead of doing this, right, we'll do this again, but you know, not for all of these steps. If I do this, go back to the front, then run that, encode element, attributes, child nodes, node name, data, attributes, child nodes, node names, data. Okay, so child nodes is actually a different kind of structure. So we actually want to encode children here. Enc child node. Right. And then it's kind of like that. So that's really just gonna be data dot node name data dot data. Boom. And then decode child node is gonna be node name data 0 data data 1. Like that. And then here we're not encoding elements, and then here we're not decoding elements. Now data might be complex. It might be complex. Child nodes, area 1. Child nodes, text data 0, data 4, text data 6, text data 2. What if we output like Only child nodes when there's child nodes. And then we'll just do something like this. And then we don't output this. And then we'll do more than 10. And then we'll get a bit of an idea of what's going on. Like this. Node name tspan attributes. Attributes. Wait. Huh? What am I outputting? Child nodes. Node name attributes. Oh, they themselves can also have child nodes. What? Wait. They suddenly have attributes. Node name attributes. All right. I'm gonna have to be smarter. The problem is the array doesn't really easily support optional values, and I don't want to put nulls in there and all that stuff. I thought they might be convertible to. I mean, they're. Yeah, you see, you have a node name, and then suddenly we have attributes. Sometimes we have data. Data. And there could be, maybe there's only two kinds? Seems to be if it's a text node, it's data. Otherwise, it's something else. I think we might have to... okay, what I'm thinking is like I can do a similar scheme here. I can have a number that identifies a type, and then the rest of the elements are, and then basically currently there's two types, right? There's one with attributes and child nodes, and one with data, right? And both of them have node names. But I don't know if that's reliable. Excuse me. So I guess we'll take a look, right? So switch if I almost wanna check it against the keys, right? So if I say let keys equals object.keys data, and I'll stringify that, or I'll just say dot join by comma, and then I'll say if keys equals node name comma data, console.log type A, else if keys equals attributes child nodes node name type B, else console.error unknown type. I do something like this. What does that look like? Unknown type, node name, attributes, child nodes. Okay, node name, attributes, child nodes. All right, let's do that. Node name, attributes. Okay, so we have node name. So attributes is optional. That's the last one. Okay, fair enough. Okay, and if we do that for the full 187, again, this might be a problem with other playback data. Okay, so far we only have these three types. In fact, we only have two types, B and C. There doesn't seem to be a type A ever. Ah, wait. So we want to do int element here after all. Hey guys. All right, so we have A, B, and C as the only types that I can find. All right, so now we're gonna return an array that's just gonna be data.nodeName, data.data. That's our type A, right? Then we'll return something. This shape attributes. Actually, no. You know what we're gonna do? We'll do this. We'll do res.push 0 0. Right? We'll do res.push node name. No, actually, we want to do this and data, like that. And then here we want to do data.attributes, like that. Right? And then finally, if data.childNodes, data.childNodes, excuse me. if keys dot okay. Yeah, I guess res.push data.child nodes.map encode element, right? I guess at this point we have to trust that we identified all the different types. So if data.data, if data.attributes, data.attributes. Right. Excuse me. So, at this point, it should encode the different types of elements with a type indicator at the start. Like that, for example, right? That would be a text element with attributes, I'm guessing, because it's a type 1, right? And if it's a type 0, yeah, it's confusing. It's confusing. But we should also be able to now decode these, right? So, node name is now always 1. And then we'll say if data 0 equals 0, or we'll say switch data 0, and we should be able to say case 0, and then res dot, if it's 0, we have, wait, we have data, res dot data equals data 2, and break, and case 1, res.data equals res.attributes with data, right, break, and then if data 0, 1, 2, if data 0, 1, if data 3, deck element. Okay. So if we're going back to go back to our other setup now, and we'll do one at a time. We go back by one, and our encoded steps should look very similar to our decoded steps here. Or our encoded and decoded should look the same as the original ones, minus what I consider optional information, like the element data when we're removing, and when we're adding. When we have child nodes, what does that look like now? We have add element, child nodes, and now this is in text and data 7. Okay. So now the question is, can we apply our decoded diff as if it was the regular diff? I would expect it to fail because I'm not replicating their element wrapper, but maybe they don't care about that. That looks good. Yeah, that looked good. So now I'd like to kind of want to do this for multiple steps, but this looks pretty good. I actually need a break right now. If this works this way, this might be viable. I don't know if I'm super fond of it. I was hoping that I actually could just write the diff into the SVG as valid SVG data, just in a hidden format. But it looks like the SVG data itself would be too chunky. Although all the stuff that I'm eliminating is actually appears to me kind of diff specific stuff. Like all the attribute names and stuff of the actual data is maintained, right? All I'm getting rid of is the extra strings that the diffs introduce. And I guess the routes are a bit weird. So I can probably still write these in a SVG compatible format, right? So we'd have a group. Inside the group, we would have the diff items, and then the diff items would just have some attributes, and yeah. It's, I don't know. It'll add a bunch of extra characters to store, and I might not like that, especially since each individual item still isn't a valid SVG data, right? So I probably want to store these separately, either as just JSON data or just a raw string inside the SVG, and then decode it using, you know, I mean, I could still store each individual step as a G, I guess, as a G element, and then just have a string inside, right? I'll have to think about that. I don't know if it's... I'm still not entirely sure if the whole thing is a good idea at all. I guess when it comes to doing the replay, the question is this efficient to go back and forth? Because I have diffs, I don't have like frames, you know, I can just jump. So I probably still want to do keyframes, which is probably just a cloned SVG content, right? And that I could store into G groups, right? So we could say, let's say every 100 diffs we'll do a keyframe. I don't know. I'm worried that I have to build the whole thing before I can tell if it's useful. Like, is this better than having a GIF, deconstructing the GIF into individual frames? Because, for example, the GIFs I generated, once I removed the duplicate frames, it got really compact, right? But the GIF is also resolution dependent. So if I wanted to have it to be in higher fidelity, the GIF has to be bigger, right? Although I suspect with the duplicate removal and the like, basically, the way it compresses non-changing pixels as transparency, it should be good. The other problem is then the renderers usually struggle to replicate. Like if I step through it backwards and forwards, it generally struggles because it doesn't know what to remove, right? So even then, we kind of still want to have keyframes, and then we basically want to jump to a keyframe and then reproduce the changes since there. And I don't really want to encode that into the GIF itself. So data size-wise, the GIF might be a good way of encoding it. But it would mean that on the playback side, we basically have to manually generate the images out of that GIF data and then deal with that, right? And decoding the GIF data is probably not fun. So, for example, one of the players I was looking at, like this one, for example, I haven't even looked into it now yet, if they actually decode the GIF data themselves in JavaScript, or if they somehow use the rendering of the browser and somehow extract the frames. And I don't know if they can do that. So, like, this feels weird. Like, this feels too little code to do the GIF decoding, right? Player. Sports. Parser. No, that's not what I thought it was. Player. Wasm-based player. Wait, is this circular? This wasn't based parser. So this is Rust based. But it still doesn't seem like it's enough. That it's enough code. Unless it's kind of importing the GIF decoding from Rust somehow. No, wait, no. It's looking at the data here. That's it? That's all you need to decode GIF frames? Seriously? But how does this convert it from GIF to something else that we can use on the outside? Parse this object unit. Just load images function callback function. So load images. Call to this JS value from string URL create object URL with media source. With create object URL with blob media source. New with buffer source sequence JS value from JS blob data unwrap. With blob. So new with buffer source sequence. Oh my god, who comes up with this naming? All right, JS blob data. Which data? I think it generates individual GIFs with the individual frames in here. Okay. I mean, that's probably reliable enough. The question is, like the example that I'm using, how does it actually, like, what actually gets loaded here? Yeah, so these are the individual frames, and I'm suspecting these all individually are GIF files. Yeah, okay, so that I would get. So decoding the animated frames into individual valid GIF files, that makes sense to me. The question is, how does this work? It's 35 kilobytes. Okay, so it does inline whatever Rust libraries and stuff were being used, and then it gets all turned into freaking Frickin' VASM. All right. 34 kilobytes of VASM. All right, for like a 20-line Rust file. Couldn't they just implement that in JavaScript as well? All right, so. And yeah, the decoder is almost as big as the GIF file. All right, and most of that is in this little VASM file. Okay. I mean, that code doesn't look terribly complicated. Like, I must be able to translate this to JavaScript, or am I maybe barking up the wrong tree? Like, does this do a lot of binary bashing around that will be a pain in the butt to do? Probably not. Does it use any big libraries? I mean, blob URL we have access to. From this unit, like none of this is a big deal. None of this is a big deal, I think. I mean, this might be something I could ask some of the other guys about. So the VASM specialists on the server. I mean, I feel like it's doing a relatively simple thing. And then on the outside, so the parser, parser, find parser, parser.parse. Where's the parsing done? Parse this, target response, area buffer, this load shift frames, check queue stack, then resolve, catch, yada yada yada, resolve, load and parse. Yeah, so there is always the option to literally binarily decode the animated GIF, turn it into individual GIFs, one for each frame, and then just make sure. I'm thinking now, basically, if my frames have alpha in it, could I pre-fill the frames without having to play it from the first, if I want to show frame 200, it feels like I have to render all 200 frames because I don't know how the alpha transparency works, right? That's kind of what I'm doing with my replay data, but I'm guessing rendering 200 GIFs might be slightly slower. And this only applies for stepping backwards through the replay data, right? Now, if I pre-render them like that, so basically after I have my 200 frames, I just go over them again. And basically I render the first frame, do nothing. I go to the second frame, I copy the first frame and add the second frame. And I keep doing that. Then I can basically pre-build all 200 images to be all keyframes, basically. Or I could even generate my own, keyframes. Like I could say every 100 frames a keyframe and that kind of thing. It's complexity on the player side. I'm also trying to think what's simplest to put on the web page so it doesn't have a ton of custom code that does weird things, right? And the simplest in that regard probably would be just to generate an MP4 file on this and have that on the server and then just have a regular video player happening. The problem is I'm not even sure if these would look good as an MP4 file because of compression artifacts and stuff. They'd have to be pretty big to have high fidelity. But to be fair, I haven't tried that yet. Didn't I? I think I looked up. If I do FFmpeg GIF to MP4 conversion, I feel like I looked into that, but I didn't actually. Did I hold on to some of those discussions? Probably. Like something like this. I think I opened a whole bunch of in screen recorder. I don't know. Animate GIF, move flags, fast start, picks from. This option is instructed before, so the browser can load as quick as possible. Picks format for video start with different formats. We include this option specifically that has maximum compatible across all browsers. This sounds like a very old answer, although it seems to be updated. 2016, wow. So if I run this on one of my test files, right? So let's see, where were my test files? I think that'd be in here. So if we use the heart, the one that we compressed, and how big is this one? So that's 366 kilobytes, which is, again, it's not huge. I just need to know that it works in the worst case scenario, not just in the best case scenario. Right. So if I do this, I start with this one and end up with video amplifier. That's fine. Right. And that's in GIF player examples, right? Right, so if we run this, let's see. Restore there as well. All right, so I did something. We have a video MP4 file. What is the quality? Like if I blow this up, yeah. So we'll probably need to start with a larger one. So if I go here and I'll say replay GIF, and I'll do 1 frame per second, that should be fine. I don't remember how many seconds this was original because this number is not right. Tell you what, why don't we load the replay data? Replay, save, load. And we have, which was the replay? I think that's the replay, right? March 19th. Boom. 540, I think it was 544. So, replay GIF, 544. That's 344, yeah, 344 frames. And now we'll make it 512 by 512. Only a little bit bigger, right? Dimensions get larger. I think it's putting some buffer around it. All right, let's create the frames. So this is expected to be relatively large. So now let's see how long it takes the animation, the GIF to be created. Yeah, 6.3 seconds. All right, we'll download it. Cool. All right. And can we convert this one directly without shenanigans? I might need quotes around this thing. It wasn't a good file name. Nope. We'll call it video 2. Then we can compare. Did I? No, it's just that fast. Holy moly. Okay. That's not right. But why is it not right? Right. I can probably. Okay, the GIF itself is broken. Why is the GIF broken? All right. But maybe that's just the easier thing to do. Like 512 by 512 should be big enough. Like even if I enlarge this, yeah, it's a little fuzzy around the edges, but it's still fine. And 140 kilobytes or whatever, it's perfectly adequate. And we might even go bigger. We can go 1080 by 1080. And maybe reduce the bitrate a bit or whatever. I might be overthinking this, and I might just be best off having this as an MP4 file with a couple hundred kilobytes for each day. I mean, it'll add up, right? But it's 1 per day. We know how many there are going to be. A couple of megabytes on the storage on the server. If there's an archive, there might be a bunch of bandwidth cost there. I mean, the GIF is still smaller. The thing about the GIF is that we don't have playback controls, right? But I'm probably overthinking this. All right. I don't know if I'll do something with this. If I'll put in the effort to actually complete the kind of data format, because it is highly questionable, if I'm honest, if this is worthwhile. But I'll hold on to the code and I'll think about it. All right, today was a weird one. I couldn't do anything significant because my brain is not functional. I don't know. I thought it was getting better 3 days ago, and somehow I didn't. The cold can smell it it can smell hope and it wants to smash it. Anyway, thanks for hanging out. Sorry about the absence. I have a lot of incredible things planned that came out of SudokuCon, and I want to talk about those in more detail. But I need a clear head, and I'll probably maybe I'll try to just do a video about it. So instead of trying to squeeze it into my streaming slots and all that sort of thing. All right. Thank you for hanging out. Take care. And see you in the next one. Bye bye.